Hey guys, so we're going to go over the notes real quick on how to do the atoms, moles, grams worksheet. Okay, so in previous videos, we have talked about the different ways to kind of move between these different, these different units. Okay, so I know that I can go from atoms over to moles. Okay, because I know that 1 mole is 6.022 times 10 to the 23rd atoms. Okay, I know that I can go from moles to grams because 1 mole is that number from the periodic table, that mass number. Okay. However, there isn't a way to directly go from atoms to grams. Okay, so if I gave you a number in grams and I asked you how many atoms was there, you would have to go and convert it from grams to moles and then convert it from moles to atoms. Okay? It's a little bit more of a complicated process, but it's not bad. So let's do some practice problems with this, okay? So let's see how many atoms are in 57301 grams of Cu, which is copper. Okay? So I'm trying to find how many atoms are in 57,301 grams of copper. Now again, I can't go from atoms directly to grams. There is no way to go directly there. So I'm going to have to go from atoms to moles and then from moles to grams. Okay? So the way that we're going to do this is we are going to do a T-chart, but we're just going to make this T-chart be a little bit longer. Okay, so instead of having to do 2 individual T-charts, we're just going to combine it down into one bigger T-chart. Okay, so I'm going to start with my T-chart. I'm going to put the thing that I know right here, and I know that I have 57301 grams of copper. Okay, now I can't go from grams to atoms, but I can go from grams to moles. Okay, so if I have grams of copper here, I have to have grams of copper down here. And I'm trying to go to moles, right? So if I look at my periodic table, I know that 1 mole of copper weighs 63.55 grams. Okay, so 1 mole of copper weighs 63.55 grams. Okay, so whenever I hit equals on my calculator, if this is all that I plug in, this grams is going to cancel, and I'm left with moles of copper. But I'm not looking for moles, I'm looking for atoms. Okay, so I do know how to go from moles to atoms. So I'm just going to make this T-chart a little bit longer. If I have moles of copper here, that means I have to have moles of copper here so that they will cancel out. Okay, now I'm trying to get to atoms. I know from Avogadro's number, or from the molar mass thingy up here, I know that 1 mole of copper is 6.022 times 10 to the 23 atoms. Okay? And then whenever I hit enter, that moles will cancel this moles, so I'm left with atoms. Okay? And I'm looking for atoms, so I need to stop right here. Okay? So I'm going to hit equals. All right? Now, when you put this in your calculator, it is going to be this number times this number times this number divided by this number, and then that'll be equals because dividing by 1 is just 1. So let's go ahead and put this in our calculator. Now whenever I'm dealing with this big number, I don't like to really mess around a lot with it, so I'm going to go 57301 times 10 point, nope, 6, just kidding, 6.022 times 10 hat 23. And I'm going to hit enter because I don't want to mess around anymore and accidentally do something crazy. Okay, so that gives me that number. Then I'm going to hit divided by 63.55 equals. And it gives me this number. Okay, so let's look at what this number is. All right, we've got 5.429, but we only want we only want 4 digits, and this is too many. So this is going to round up that, and because it's a 9, that means that we've got 5.430. Okay? Now, in here, it's got all these numbers, and then at the end, it says E26. Okay? Now, what that E means is that it is an exponent. Okay? So what that means is times 10 to the 26th. Okay? And then we are looking at atoms. That is our answer for how many atoms are in this many grams of copper. It's that many atoms. Okay? Let's do another one. Let's do how many grams are in 7.7 times 10 to the 24 atoms of nitrogen. Okay, so if I have this many atoms, I want to know how many grams, how much that weighs. Okay? Now again, I can't go from grams to atoms, but I can go from atoms to moles and moles to grams. Okay, so if I draw my T-chart, I know that I have 7.7 times 10 to the 24 atoms. Okay, if I have atoms here, I need to have atoms down here so that they will cancel each other out. Okay. Now again, I can't go from atoms to grams, but I can go from atoms to moles. And I know that there are 6.022 times 10 to the 23 moles, or atoms, in 1 mole. Okay? So if I were to hit enter on my calculator, these atoms would cancel out those atoms, and I would be left with an answer in moles. I'm not looking for moles, so I need to keep going. Okay? If I have moles here, I gotta have moles here. Okay? Then if we look at our periodic table, 14.01 grams in 1 mole of nitrogen. 1 mole of nitrogen is 14.01 grams. I can hit equals because those moles will cancel out, and I'm left with grams of nitrogen, which is what I'm looking for. Okay? Oopsie, had to re-record this part because I put it in my calculator wrong and got a crazy number. So, I'm going to recommend that whenever you're dealing with these exponents, you just overuse parentheses because, dear Lord, it can get wild. So I'm going to start putting this in my calculator. I'm going to say 7.7 times 10 to the 24th, and I'm going to hit equals. And then I'm going to say times 14.01. I'm going to hit equals again. And then I'm going to go divided by, and then I'm going to open parentheses so that it doesn't try and do anything crazy. Okay, close parentheses. And I'm going to hit equals. Okay, and that gives me 179.1. Okay, and we again are working in grams of nitrogen. That is our answer. Okay, let's do another one. All right, so let's find out how many atoms are in 427 grams of fluorine. Okay, so I know in my T-chart, I know that I have 427 grams. Can't go from grams to atoms. Okay, so I can go from grams to moles though. Now if I have grams here, I gotta have grams down here, and I can look at my periodic table and see that 19 grams are in 1 mole. So 19 grams, 1 mole. And again, I have to keep going because I'm looking for atoms. Grams will cancel out, but I only have moles. I'm not at atoms yet, so I gotta keep going. Now I know that 1 mole is 6.022 times 10 to the 23rd atoms. And my moles will cancel out. So I'm left with atoms. I can hit equal. Okay, so I've got 427 times, and I'm going to open that parenthesis, 6.022 times 10 to the 23rd, close parentheses. I'm going to hit enter, and then I'm going to divide that by 19, which gives me 1.353 times 10 to the 25. Again, remember that E means times 10. Okay, so I'll do one more and then I'm going to turn you loose. Okay, let's say how many grams are in 1.42 times 10 to the 27 atoms of lithium. Okay, so I'm going to make my T-chart. I've got 1.42 times 10 to the 27 atoms. I can't go right from atoms to grams, but I can go from atoms to moles. I know that there's 6.022 times 10 to the 23rd atoms in 1 mole. And when I hit enter, the atoms will cancel out. Okay? But I still have moles, and I'm not looking for moles. Okay? So I can go from moles to grams. If I got moles here, gotta have moles down here. I know that 1 mole of lithium, 1 mole of lithium is 6.94 grams. Oops. So 6.94 grams. Okay, moles will cancel. I'm looking for grams. I can hit enter. So I'm going to start plugging this into my calculator. I got 1.42 times 10 to the 27th. And I'm going to hit enter. And then I'm going to multiply that by 6.94. Hit enter. And then I will divide it by 6.022 times 10 to the 23rd, which gives me 16364. Okay? Now, there is a way to round this so that you can only get 4 digits, but like, oof, it is a struggle. Somebody did y'all dirty somewhere thinking that you can't round anywhere. We ain't gonna worry about it. That's gonna be our answer. All right? So, I'm gonna go ahead and turn y'all loose and let you work on your assignment. Hit us up if you've got any questions, okay? Bye-bye.